Good morning to all and welcome to the AWS webinar. Our topic for today is Introduction to Machine Learning. We thank you all for making the time. Our speaker for today is Suman Devnath, Principal Developer Advocate at AWS. You can post your questions in the Q&A box throughout the session and we would address the same post the presentation. Over to you, Suman.
Sure, thanks, Roy. Good morning, everyone. I hope everyone can hear me clearly and hopefully you are able to see my presentation. For next 1 hour or so, in case you see that you're having some issue seeing the presentation or my screen or your audio is not working, please let us know through the chat. We have a team and the team can intimate me. All right. So before we get started, I would like to thank you for joining in. I know that this is a fun topic, and we can spend a couple of hours just for the basic things. But all I wanted to give you is an idea about what machine learning is and how you can leverage AWS, to solve a few of the very critical problems that we have in hand, in the industry. Okay, so my name is Suman Devnath. I'm a principal developer advocate at AWS, and I work mostly into machine learning and data science and a data analysis side of AWS. I'm also pursuing my master's from IIT Jodhpur on artificial intelligence. So I understand that most of you are new to machine learning. So I just thought to give you an idea about what AI or ML or DL, these are the terms that you might hear, what these are, and how you can solve problems with AWS. And towards the end, I'll also discuss about the problem statements that we have from AWS for this particular hackathon, where you can use few of the services to build some a meaningful software. So what is artificial intelligence? So this is, you can think of this as a Venn diagram where the whole world of this stack is known as artificial intelligence, which covers everything. So when I say everything, that means that let's say a smart car or let's say an autonomous car. So these are application of artificial intelligence, just like drone. So these are artificial intelligence based problem which was solved or people are solving. And machine learning is a subset of AI that abstracts the statistical techniques to solve those problems. Okay, and within that machine learning, we have deep learning. So deep learning is again a subset of machine learning, which comprises of a very sophisticated network called CNNs, and to solve very critical problems like speech recognition or image classification. So these days, if you have been to airports or any shopping mall, you might have seen that you are allowed to take a boarding pass just by with your face, right? So they're using deep learning technology at the back end. So this is the whole stack of AI, ML, and DL at a very nutshell. So now, when you think about solving a problem, in a classical computer science world, what we have all learned, or you have been learning now, is you have a problem, and let's say if I give you a problem, let's say given a number, just tell me whether this number is a prime number or a not prime number. So you know the maths behind how to calculate a number is prime or not. So you know the code, so you know the solution of that problem. So you have x, and you just have to write the code for fx, and then y would be like a true or false, right? Which will say that, okay, the number is prime or not. But in machine learning, it works differently. You know the input and you know the output. What you don't know is that function fx. Okay, so that only you have to build. And how you can build that? You can build that with lots of input data. So if you take this example of a Rubik cube, there are more than these many number of possibilities that which can solve this problem, right? There are quadrillion unique combinations. So obviously, if you take a system, you cannot do it, right? You cannot write a code which can do all this, in a certain amount of time. Now, what we can do is, with machine learning is, let's say I have given you a Rubik cube, and you have come up with a solution. Now, that solution may not work always, considering the input state of that Rubik cube, right? So, but let's say with one data point, the accuracy of that function may be 1%, right? Similarly, I've given this Rubik cube to somebody else, and he has solved it, and now I have two data points to solve that Rubik cube. So now the accuracy increases, right, to 2%, or let's say 3%. Similarly, if I continuously, give lots and lots of data, so it's like enormous amount of data, and with its solution, what happens is you can build this, learning function, or you can think of as an FX, to make a very right prediction. So after that, when you give a problem, right, it can certainly give you a solution with much high accuracy. So always remember that in machine learning, it's all about prediction. So when we say prediction, the next question you will ask, that how confident is your prediction is. So let's say you ask me about, you ask a, computer model or machine learning model, saying that, okay, take this picture and tell me this picture contains an image of a chair or not. So that model might say true or false, right? It would be in a Boolean. But the next question that you would be interested to know is, what is the confidence level of that answer? So whether it's 5% or 10% or 90%. So you have to take always the actual prediction and the accuracy. Now, if you take this, if you look at this, the same Rubik cube can be now solved within, less than a second, with these many number of input data points, and you can build a model using very sophisticated algorithms that we have in machine learning. So the basic idea is you don't have to code the pattern. You want the system to learn from its own. Okay. So there are, now how it can learn of its own. There are a lot of statistical tools. There are a lot of statistical algorithms which are available, which you can use to leverage that. Now, this is what we call the machine learning approach. So this is how you can tackle a problem which do not have a standard formula to solve it. Now, there are different types of machine learning that we have, or you will see in the industry, or if you if you go to the problem statements, you will find it can be categorized into different types of machine learning. So the first type is supervised learning. So as the name suggests, it's a supervised learning. That means the data that you put in, those all are labeled. Like, let's say I've given you a problem that, okay, you have to write a model, or you have to develop a model which can identify a human being or a dog in an image. So that means what? You have to have lots of images of human being and lots of images of dog, and every image need to be tagged. Like, in this case, you might have an image and it says it's a kid. You might have a dog and it might say it's a Labrador, or it's just simply a dog. So you need to have this amount of data sets, and all these data sets are labeled, so you know what this data is about. And later on, you can build a training data with this input images and the labels. Okay, so this is what why we call it as supervised, because you already know the input data very well, and you can already you can classify or label those data. And once you have that, you can use one of those machine learning algorithm with this input data and come up with a prediction. Okay, so this is what is very critical. So in this case, this input data for supervised learning is very, very important. Just like in a while back, we have seen the example of Rubik cube. If we give just one solution, or one of the possibility to solve that, you cannot make a very good model. So, but if you give hundreds and hundreds and hundreds of probable solution, you might be able to get a better model which can predict the solution with a different combination, right? So it's all about the training data, and the more data you have, the better it is. Now, once you have that model ready, then you can do something called inference. That means once you have that data, and once you use some algorithm, then you get something called a model, and that model can be used for inference. So what is that inference? So you can think of model as just an artifact, or you can think of just a program. It's not actually a program, it's a set of files, but you can think of that just like as a program. And then you can just go and do an inference. That means you just go and ask that program or that model that, okay, now you take that image and tell me this image contains a dog or a human being, whatever it is, and it should be able to predict with some confidence value. So there is another type of machine learning which is called unsupervised learning. So as the name suggests, here you don't have the data labeled. Okay, so there are many cases that you can have these kind of problem. And one of the example would be in your email. You might have seen that there is a spam folder, right? And you see that once you mark a few of the emails spam, it tries to figure out emails which can be like that and classify it as a spam. And at times you might have seen that a real email have gone to the spam folder. So it's kind of a classification problem. And what that model does is unlike creating doing an exact prediction, what it can do is it can classify a certain data with some certain properties. So let's say this is an x and y axis and you have lots of data point. What it can do is it will see the data and it will try to make different classes based on the locality or whatever it is. So it's like no human intervention is needed, but you need to do a segmentation. Okay, so this is what unsupervised learning is about. Now there is one more type of learning called reinforcement learning, but that is not being rampantly used. But for now, for the basics, you need to know mostly the supervised learning and unsupervised learning. And supervised learning is the one of the area where most of the problems can be solved, and most of the problem that we see comes under supervised learning. Under that, you have two different types. One is classification, another is regression. So classification is just like a spam detection, as I mentioned. So you can classify certain thing into a category, right? So there is the output may not be an integer, output may not be a number, but the output would be some class, right? So let's say detection of spam emails in your inbox, or or who are the people who goes to church, those kind of thing, who are the people who goes to a mandir, these kind of things. So it's just a kind of a classification. And what is regression? So regression is where your output, the model should give you an output with specific numbers. Like if I ask you what is the property price in New Delhi, so you have to give me an answer, right? So let's say X amount or Y amount, whatever it is. So those are kind of a regression problem. And there is certainly there is an unsupervised learning which is based on cluster segmentation, which is again kind of a you're classifying it but in a clustered fashion. But there are other types of machine learning also there, like reinforcement learning. But primarily most of the problem will come under these two. Now, what are the things that you can do with AWS? Now, if you look at AWS, AWS as a platform can give you a lot of flexibility to solve these kind of machine learning problems. And if you look at this ML stack, this is what we at Amazon or at AWS have defined different types of services. Now, in the very bottom layer, this is mostly for data scientists and researcher who knows all the algorithms. They know nuts and bolts of the system that is needed and all that. And they also know what are the frameworks which they are, they can solve problem with. So they just need a platform and they will build everything from their scratch. So obviously, this will come with a lot of flexibility and you can change, tweak a lot of things of your own. And then there is a middle layer, which is ML service, and where the Amazon SageMaker comes in. And this is the area where most of the data scientists or engineers would try to work on. And this is very, very comprehensive. You can build a model, you can train a model, you can deploy a model, you can do prediction, you can do everything. But you don't have to worry about the backend infrastructure for it. So everything is kind of managed. So in this stack, the higher you go up, the less knowledge of machine learning you need to get started. right? And in the very top layer we have AI services, which is kind of API level services, where you don't have to build a model. So model is already there. You don't have to come up with a training data set and all that. The model is already there. You just have to go and ask the model what you want to do. That's all. So just like a simple curl command, or you can say, you can just send a API request to different services to get the response, right? So this is very very useful for any software developer who wants to use machine learning into their application, but they are not from machine learning background, right? So you can always get started with this. So we will see some demo with on AI services, and we will try to see if we can see some demo with SageMaker if time permits. We'll not look into the last layer, because that is kind of an infrastructure layer, and which may not be relevant for you at this point in time. So with that, let's see what are the AI services that we have. So there is one of the service that we have called recognition, where you can give an image, or you can give a photograph or a video, and it can recognize what that image contains. So again, you don't have to build that model. So this model is already built, and it gets updated very frequently by Amazon. What you can do is you can simply upload an image and see the items that that image contains. Okay, but obviously you may not find all the items as you wish, because the training is not done by you. The training has been done by AWS. All right, so let's say you take a picture of let's say a traditional food, let's say biryani, right? And then you take an image and send it to a recognition. The recognition might give you a response saying that it sees a food item or rice, but it may not see that that's biryani, because it was not trained with biryani as a label with some training data set, right? So that flexibility you will not get it at recognition. There are now custom label enhancement feature available, which you can do this. But in general, the point I'm trying to make is you can do it at API level. You don't have to spend time on building the model. Similarly, there is another service called Poly, where you can give any text, and it can convert it into a speech, right? So these are the things which is heavily used in a Amazon device called Alexa. You might have seen that. So that also uses these kind of services. There is another service, very very effective service called Comprehend, where if you give a text, right, it can do an analysis on the sentiments, and it can also identify the entities from that text. So let's say you give a text that says okay, you are a very bad person. So automatically you will see the response of that API call under sentiment would be negative, right? So it's like that. So you can simply do an analysis on your text. You can also do with Comprehend, you can fetch informations like entities. It will automatically detect, like, this is a text which we have passed, and if you see, it has already detected that Amazon.com, it's an organization. There is Seattle, so it is a location. So it can automatically detect the entities and key phrases from the text. Now if you look at ML services, that is SageMaker, which is the most important part of AWS ML stack, and most of the people in the data science world would use this, is the Amazon SageMaker. So there are many customers that are using AWS for not only for machine learning, but for other services. But for machine learning, Amazon SageMaker is very popular across data science. So if you look at the machine learning model or the pipeline, you will see these are the things that you need to do, right? You need to collect data, with label it. That is, we are talking about supervised learning here, and then you have to clean that data. That also takes a lot of time. Then you have to develop a model. This is where you come up with a few of the algorithms, and you then start training that model using the data sets that you have. And then you have to evaluate the model and do some adjustment with some hyperparameters and a few tunings. And after that, you can do some prediction. So this whole thing is a continuous process, and it takes a lot of pain to do all of that. So with the Amazon SageMaker, it provides a certain things which can solve this problem. So there is a within Amazon SageMaker you have ground truth, which can do data collection and labeling. Then you have notebooks. There's just like Jupyter notebooks. If you have seen, if you have worked on Python and data science, I'm sure that you are familiar with notebooks. So notebooks are nothing but a Python interpreter, on the browser, and you can visualize things, and you can do a lot of fancy things there, which may be a little difficult to do in the normal command shell. So it's Jupyter Notebook is a day in day out thing for any data scientist. And then you can do the training, and then you can finally do the inference. Everything is covered by Amazon SageMaker, and you can do whatever you want on SageMaker. So if you look at the console, it would look like this. We will do an hands-on in some time, so I will show it to you. And first, let's talk about ground truth. So ground truth is where you can label your data. So let's say you have an image and you want to label this data. You can use ground truth for that. And if you have a lot of data and you don't have data at all, then also you can use ground truth. And ground truth will help you to do that labeling for you. So it might be crowdsourcing. It might have send that ask certain amount of people who can do a data labeling for you, because you may not have all the data with you. So ground truth is a very easy way how you can label your data. Then comes the notebook, which I've just mentioned. It's just like a Jupyter notebook, but the difference is it already comes with a lot of packages that are relevant for machine learning, like scikit-learn, PyTorch, TensorFlow, and all that. And if you look at it, if normal Jupyter, when you go to this, kernel selection page, you see only Python 2 or Python 3, things like that. But here you will see, all different kind of framework, and you don't have to manage that. So everything is managed by AWS. So if tomorrow, PyTorch comes up with a new version, it will be already available to you. And the next thing is the training. So here only the main engineering lives. So here you have to write the a code for building that model. So Amazon SageMaker comes up with gives you a lot of ready-made recipe or a lot of algorithms by default. So once you open the Jupyter notebook, you can have various algorithms on various topics. Like few of the algorithms are tuned with AWS, so you can use XGBoost, Linear Learner, and all that through SageMaker, and it can also give you a lot of other algorithms on reinforcement learning, deep learning, etc. But everything is under the same platform. So this is how it basically works out. So this is your laptop or the dev desktop, you can think of like from where I am working now, and you open an Jupyter notebook. So this is just like a Jupyter notebook, what you have in your laptop installed directly on your desktop. But here, this is a SageMaker notebook, which is actually built on top of some virtual machine at AWS or some container. And then from there, you can do the training in some different instances. And then once the training is done, you have that model, and then you can deploy that model into another EC2 instance, or any container for that matter. And then you can start working on the inference. So this is how the training job works. So this is the above is through UI, and the bottom is through Python SDK. So we have a model called SageMaker and Boto 3. So Boto 3 is a general model which is there for any resource if you want to use in AWS through Python. And SageMaker is the specific model for Amazon SageMaker. So you can create a session, and then you can do an estimate. So this is where you create a model, and you will give a container which has that framework that model is built on. Like let's say a container can be of PyTorch, it can be of TensorFlow, whatever it is. It will have all the modules and binaries for that, and then you say that how many instances you want for that training. If it is a very big training, you might want to do a distributed training, maybe 10 instances or 10 virtual machines. You can specify that, and then you have to define what type of machine you want, and then you have to define, once the training is done, where it should save the model. So you define the output, and then you give some hyperparameters or for tuning, and then you start just by running dot fit in this example, which will start the training. And when you start the training, you have to give the training data set, right? So this is what the training data set is. It's as simple as that, and everything would be managed by AWS in the backend. So this I already mentioned, and we will see in the demo as well. But this is a Python SDK. So AWS have two SDKs, one called Boto3, which is for any AWS resource, and another one is SageMaker for this particular entity. All right. So the last thing is that we have is during the training, you can have lots of built-in algorithm for regression and classification, for clustering, for computer vision, and all that. So you can have a lot of inbuilt algorithm which you can use through the Jupyter Notebook. I'll show it to you, when we go to the hands-on. And the last part is the inference. So inference is when you already have that model. Now you have to start inferencing. That means you have to start predicting, right? So you have to deploy that model somewhere. So you can deploy it in a virtual machine, or you can deploy it in some IoT device like a camera, or maybe a system which is remote, not in AWS. You can deploy it there using Neo, and also you can do some fun project using few of the machine learning devices that we have at Amazon called Deep Racer and Deep Lens. So Deep Lens is an AI-enabled camera where you can deploy the model directly, and then that camera can do the inference. And when you connect this camera to a monitor, you will see the annotations or the prediction on that monitor itself. Okay, so let's say you have built a model for face recognition and you deployed that into deep lens, and after that, when you connect that camera to some place, let's say in front of your gate, then the moment anyone passes through, you will see an image of that video, but also a small bounding box across the person's face. So that's what inference is, and that's how it will annotate that video stream and it will pass it on to you. So before we go ahead with the other things, let me show you some demo. So let me first show you some demo on the AI services. So which is the high, upper stack, which we have just seen. So let me show you what I'm going to show you now. So let's see about this one. So we are talking about all these AI services that we have, okay, all the top layer services. And first we will talk about recognition. So let's see how it's looked like. So I just logged into AWS, and I just search for recognition. And here I can simply come and do a object detection, or let's say I upload a sample object and it says that it is a city, it's a building, and all that. Okay, so let's do some. So this is in the console, and surely that this is just for just to see what it can do. What I have done is I've created a small website, and this is written in Node.js. You can always see that it's AI-services-demo .go-aws.com. You can keep a note of this if you would like to. So let me show you a live demo of recognition. Okay. So if you see, as I'm speaking now, I just click on this detect label. Okay. So it should detect that there is a face in it. So if you see, it has detected a label called face. It has detected it's a human, it's a person, and all that, and with confidence level. All right. So let's try something else. So I have a phone. So let me uh, take an image of this and click on detect. So if you see, it has detected there is a phone 99%, and if you see, it has also detected iPhone, which is pretty interesting, right? So this is what the recognition is, right? And let's try to do a demo on comprehend. Okay, so at the back end, we have written the code to call that API, and it is just sending that API, and the response is coming in the result. Okay, so let's say I type something. Okay, so let's say thank you for joining. You all are awesome. So I just clicked on analyze the text, and it says, and it's a positive and a sentiment, and it's almost 99% positive sentiment, and it doesn't detect any entity because it's a normal text. There is nothing much in it. But if I say something like this, let's say, welcome to Amazon. If you see now, it has also detected an entity called organization, and the text is Amazon. All right. So these are the things that you can do, and with simply by running an API, sending an API. So these are the methods that we have used, for these kind of prediction. So now if you want to see the code for that, let me show you recognition in Python. So this is just a simple Jupyter notebook. And what I've done is I have imported this module called Boto3 and a few other models for image recognition. So what this function does is I will be calling, the recognition API, and I will be, returning what that image contains. Okay, so I've just written a small wrapper function called show faces, which will take two inputs. One is a photo, another is bucket. So bucket is a terminology that we use in a service called Amazon S3. So Amazon S3 is a service where you can put your documents. So it's a object storage service from Amazon, and what bucket is, in a nutshell, you can think of it as a folder, which is not actually, but you can think of it as a folder, and the inside that you can have any number of files. So this particular function will take that folder or bucket, and within that it will take what photo or what picture I want to send to recognition to detect what that object contains. So how we can do that? I will create an S3 object, and I will get that object using object method, and then I will just wait for the response. Okay, and once I get that, then I know that the details about my file, right? So I just converted into byte.io, and now this image contains the photo, right, which is stored in S3 as an object. And this is the main thing. So here only I'm calling that face recognition API. So how I'm doing it? I'm calling a function called detect face, and I'm passing the bucket and the photo, and I'm storing it in a variable called a response. And after that, what I do is I just put some bounding box across that image and all that. So this is not that fancy, but at the end, I will just draw that those lines across that image, and I will show that image, and I will also print what are the face details. So this is a face detection API. So before that, so if you look at this function, there are two things is needed. One is photo, one is bucket, right? So I need to know which bucket I should use. So I just run this command, AWS S3ls. This is a Linux command which you can run from your Jupyter notebook, and the output is, it will tell you all the bucket names. And I know that I have some images inside this bucket. Okay, so I just do an ls for that, and I see that there are 3 images in this. So now I have saved 2 variables. One is bucket, another is photo, and then I simply call that function show faces. Okay, and then I just print, what are the faces got detected. If you see in this image, it detected a couple of faces, and it has also detected what is the age range of these people. So there are 5 people there in this image, and it has detected 5 people, and with also the image, sorry, the age range. Okay, so it's pretty interesting. Right, so you can do this in just hardly any matter of time, right? We have not built any model, we have not done any training. What we have simply done is we have stored that image in an S3 bucket, and after that we just called the recognition API. That's all, right? So there's hardly anything that we are doing. So the same thing was happening when, in this case, when I went to uh, 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 recognition, and the moment I hit this detect label, from my browser, that image got stored in S3, and from S3 this particular request was called, right? And then we got that label in the browser itself. So similarly, you can have another service called translate, which will translate your the data to a different language. So here I've again created a small wrapper function, which takes 2 arguments. One is the actual text, sorry, 3 arguments. One is the text, second is the source language, and third is the target language. And I simply create a translate object using Boto 3, and this is again one line of code, right? I just call the translate text API with the and passing out that text and the source language and target language, right? And I just have a small hash, which is a dictionary which contains all the language that are supported till today. So Hindi is now supported, as you can see. So now if I just simply have a text, let's say, hi, my name is Suman, thanks for joining this webinar, and I know that there is an English, but I want to translate it into Hindi. Okay, so I just run this, and I see that it got translated into Hindi, right? So similarly, you can do a lot of these things using various other services like comprehend and all that, which does sentiment analysis and all those kind of things. So this notebook, I have uploaded. I'll share you the link towards the end, but this is how how simple it is to get started with AWS using AI services. So now going back to the slide, if you look at this, we have covered all the mostly the AI services, right, which doesn't need you to write the code to build the model and all that. Now the second thing is the ML services, which is SageMaker, and this is where you have to write your code to build models. You have to train your model, and then you do the inference, right? So let's see SageMaker, how it look like. So I'm going to the console, I'm searching for SageMaker. So now if you see in the left hand side, you have all these things like ground truth, notebook, training, inference, and all that. So in the notebook, if you come to notebook instance, if I click on notebook instance, you can simply create a notebook instance, which is kind of a, you can think of a virtual machine that is getting created on your behalf with the Jupyter notebook, and it will have all the binaries and frameworks already installed. So I have already opened this notebook. I'll just show you how it looks like. So it will look like this. the Jupyter notebook, and here if you click on new, you will see all the different kinds of frameworks, right? And you don't manage this because this is running on the cloud, and you don't have any control over there. But what you can do is you can write your code anywhere on this world, right? As long as you have an AWS account, you can share your code, you can do a lot of collaboration and all that with lots of ease. Now, if you remember, in the presentation, we have seen a lot of algorithms, right? These algorithms for training, right? All these algorithms are already built in, in SageMaker. So to see this, you just have to come to SageMaker examples, and here, you have lots of algorithms and default notebooks. So let me show you one, so how you can use this. So here there is an there is a notebook called with scikit-learn. You can just preview this. It will just show you what this contains, and here you cannot run it, okay? But if you have gone through this and if you like it, then what you can do is you can simply click on use, and it will create a same notebook in your SageMaker instance. Okay, so after that you can start working on it. Okay, it's as simple as that. But there are different algorithms which are available, right, in under every tab. So you have a lot of algorithms for reinforcement learning, AWS Marketplace, and all that. So you can explore, as you start, working on SageMaker. Now, there is there is one notebook, or there is one problem which I thought to show it to you, but I don't think that we have enough time. But I will just show you very briefly what this contains. Okay, so this is a problem of machine learning using XGBoost algorithm, which is a decision tree based algorithm for based on gradient descent, so for supervised learning. And the problem is, we have lots of data for movie and with its video games with its rating, and we have to predict for any media company that a particular video game is a hit or not, right? Because these are very important when any video game company launches a new game. They should know what type of game is is something that they can make most profit with, right? So if you look at it, I again have a bucket, and I just have a prefix, so that I know that inside that bucket all the files whatever I am going to use for this project comes with this prefix. And then I imported few of the models which are needed for my work, like general models like NumPy, Pandas, Matplotlib, scikit-learn, and all. And I download the data set. So this data set is available in Kaggle, so you can just download. And if you see the data, it looks like this. Okay, it has name of the video game, and then the release, the genre, who is the publisher, and the sales of various regions, right? All the informations are there. So now if you see this, it contains 16 columns. So in data science or machine learning, these are called 16 features. So these are nothing but these column names. So every column is termed as a feature, right? So now I have to predict whether a certain game is having high sales or not, right? So I will create a new column called y. And now how we can do that? So let's say, for the sake of simplicity, we just make it as hit if the global sale is more than 1%. All right, so sorry, the global sales is, yeah, more than 1%. So if you see, all are true, right? Everything is true. There is there will be, if there is no sale, then it would be false. So they just for for the basic additional of feature, we are just doing it. So if any game has been ever purchased, then that is kind of we are saying that that game is working. Okay, then now we will develop a model which can define that there is a hit or not. Okay, so So obviously, if you see, if I plot that, I will see that there is most of them are not hit because they don't have any sale, and there is very few number which is of hit, right? So now, obviously, this, if you start building a model with this, it will be very much skewed because it doesn't have enough data for hit. So we don't know that when when a new video game name comes to this model, it may not be able to predict whether it would be a hit or not, right? So, and obviously we define this label using only one feature, that is global sales, which is also not correct, right? So we have to take care of other features or other columns. So we did we have taken few of the other columns, like user score, critic score, and all that, and we have just put plotted in the graph. And if you see, the higher is a user scale, user score, the global sales is also quite high. But at the same time, you see that there are a lot of video games which has less score, but still have a good sales. So you cannot just do an if condition and create a model, right? So that's why we need to use some machine learning algorithm like XGBoost. So what I did here is there are a lot of unnecessary columns. I'm just dropping them all, and I've just stripped down that data set like this. Okay. And then if you see, there are a lot of data which are with NaN, which is kind of null value, so it doesn't have any entry. So I'm just dropping them all, and once that is there, I see that a clean data with all the scores without any null value. But there are few values which are, if you see, TBD, which is like to be decided kind of. And if you see that the user score is in the scale of 10, whereas the critic score is in the use of in the scale of 100, right? So we need to make sure that they are into the same scale. It is not necessary, but what we can do is this to be decided, I can convert this with let's say I divide this by 10, right? Because if you look at these two scores, which are quite similar, right? It is like 91%, it is 8.6, there's 80%, this is 7.7. So there are two ways I can clean this data. Either I will drop all the rows with TBD, which will again shrink my data set, which I don't want. So what I can do is simply I can just make some changes by computing this TBD data with let's say by dividing this critical score by 10. Okay, and after that I kind of have all the data, and then I used something called one hot encoding. Okay, so what one hot encoding is, it will add more columns or features based on the category. Okay, so if you see here, the publisher is Nintendo, then Microsoft Game Studio and all that, right? So let's say there are 10 different publishers. So after you do one hot encoding, what will happen is it will create 10 more columns. Okay, one with publisher underscore Nintendo, another would be publisher underscore Microsoft Game Studio, like that. And then for a particular item, it will have one only on the respective producer. Okay, this is just like you are expanding the data, but what it you know why it is useful is in machine learning, you will have all the data in 0 and 1, right? So it is easy to develop that do the training in it. So if you see, there are different platform, and all all the different categories of platform have got a new column, and then there is a three small dot. That means there are a lot many columns there. So this is what one hot encoding is, and this is generally very much used in machine learning, right? And once you have the data, I split the data into training data, and validation data, and the test data. So training data I will use for training, validation data I will use to validate that model, and then test data is actually the data that I will use for inference at later point in time. So I'm using XGBoost. So for XGBoost, you need to convert the data into a certain file format called libsvm. So how that data looks like is, if I just go back and show you uh, how that file looks like. Let's say I just click on this .libsvm. If you see this data, you see all the numbers are in numbers, right? But in the first place, this number is nothing but the label. Okay, 0 1 0 1. So 0 is no hit, 1 is hit. Okay, this is how that the format converts the data to. Okay, so now if I go back, what I have to do is I have to drop that column, and then I have to create a new column called 0 and 1, right? And you have to give the file name, whatever file name that you need to store the data to, right? So again, I've created three files. One is training data, validation data, and test data. And then here comes that SageMaker thing where I have to start the training. So I have to say, what container or what system that the training should be done with. So since I'm using XGBoost, I'm taking an XGBoost container. There are different entries because AWS have different regions. So in every region, there are the path of that container is different. So that is what there is just a hash. If I'm running this in US East 1, then it will use this container. Okay. And after that, you have to do some, create a training parameter where you have to define, the source of the data, that is the training data, then validation data, and all that. And once that is done, you can simply start the training, right? So how you can do the training? You can create an object called SageMaker, like using Boto 3, and then you can create an object with all the parameters that we have just created. Okay, that create training parameters. Okay, now once that is done, you can keep waiting because it will take some time, right? So there's just a try finally clause which will wait for this training to complete. Once the training is complete, you have to host that model. So you have to deploy that model to some some instance. So again, you have to create a model, and you have to define where you should define the model. So again, I'm using that container which I've previously assigned to use that as a deployment a host. And once that is done, you can deploy the model to some endpoint. Okay, so this is where you will do that inference too. Okay, so once you are done with the deployment, you will get an endpoint. So endpoint would be something like this. Okay. So now once this endpoint is available, now this can be hosted through your website or some web browser or whatever it is, and you can do an inference. So you can share the details, and it will predict whether the movie is a hit or not. So now if you try to do an evaluation, um, that is the prediction. If you see, we have passed a test data set using test libsvm. This is a file which we have saved in this format. Before, if you remember, we just split that data before the start of the training. It got an error rate of almost 13%, and for all the test data set. So that means if you look at this test file, there are lots of movie data, right? So what it has done is it has calculated, it has sent this data this much, and it has calculated that whether the movie is hit or not, and then it has compared it with the actual label. Okay, 0 or 1, and then it has predicted that whether the prediction was correct or not. Now later on, if we use a confusion matrix, whether the column name is actual prediction and the row name are the real labels. So that means this column if you see this cell number 64, if you see this, the column is the prediction, right? The outcome of that model. So it says that it has predicted 621 times that a movie is not hit, and those all are correct. But it has also predicted 50 times the movie is hit, but it is actually labeled as 0, right? Which is not correct. So these are the errors, right? So this is how, in the confusion matrix, you can easily see that out of total 60 plus 72, right? These are actual hits. It has already able to predict 72 hits correctly, right? So, and out of how much, 621 plus 50, it has able to predict 621 times correctly, right? So this is how you can use SageMaker to build your model easily with the built-in algorithm, and you can start writing the code on the notebooks. Okay, so if you want to have a look into these notebooks, or if you want to see the code, you may like to go through this website, or I've just shared this notebooks. So it's speaker deck hyphen DBNSUMA, and then even if you don't if you just come here, because you may not be able to see this, you can just download these two notebooks, and this is the presentation that we have used today. So these are the three presentations that we have worked on today. So you may like to explore this. So I know that we have rushed a bit, but this is what I wanted to show you. And for more information, you may like to go to our website, ml.aws. There is also an ML University where you can get free training, and you can write certification as well if you wish to, right? So so before I stop, you may like to take a moment and scan this code, and you may win some free credits of I guess $25, and you can use it during your hackathon, or maybe some of your personal project, whatever it is. So with that, I will I'll just explore a few of the questions. I guess we got some questions, or I'll go back to Roy. So we got lots of questions. So I may not be able to answer all of that in uh, at present. But is it a paid service? Yes, it is a paid service. But you will get some in the under the free tier, and you can use the credit that you will get today. Or what exactly is the confidence? So confidence is a percentage that when a model has predicted something, it will give you some with some confidence level, so that you know that uh, uh, how accurate that confidence is. So this is being calculated by the algorithm during the using a loss function. So depending on different algorithms, it uses a different loss function, and it calculates that. So with that, I will let our moderator to check if we have anything specific. Hello, can you hear me?
So we have questions. We've assigned them to you. I am going to pass on a couple of more to you.
Okay, sure. So what what I'll go through in next 5 minutes or so is or 2 minutes. I'll just check the questions. But for others, you can ping me over Twitter or LinkedIn. I will try to answer that. Okay, so I'll just go through the questions quickly. Okay. What is Amazon Translate? So Translate is, you can convert from one language to another language, like English to Hindi, Hindi to English, and all that. So that you can use for as an AI service. What is XGBoost? So XGBoost is one of the algorithm that we have for supervised learning, which is based on decision tree. You may like to read that, over the internet, but it's basically, it classifies thing into a tree structure, and it asks question. So let's say you have a lot of a data set with various columns, and it may ask that, one of the column is, let's say, gender. So in the decision tree, maybe the first thing is whether the person is male or female. If it is female, then it again branches to a different question, and that's how we keep on doing till it gets to the leaf and come out with some prediction. So you can explore that. Then I have one question. Where can I get this Jupyter files? Yeah, I've stored that. I've shared you the location. It's speakerdeck.com/DEBNSUMA. The first four letters of my name and my title. Is this AWS account free for use? So not, it's not free. For all the services are not free, but you will get few services under free account. So you may like to use that, and you may like to use the credit for that. So if I'll just go back to, just 1 second, I'll just okay. So you may like to get some scan it if you have not yet. I will take two more questions. Uh, can't I check it in Java, C programming? Yes, surely. There are few SDKs available for Java and C Sharp. So you may like to explore what we have discussed today in Python. Can I download this notebook? Absolutely, yes. I've shared that. Are there any course on ML University? ML University, everything is free. You can take any course. These are the courses which employees goes through. So you may like to explore that. It's completely free. One more question. What was the criteria for detecting the age? That's a very good question. So we have seen that the age got detected because the training set that has been used for face recognition are labeled not only with the image, but also with the label of age. So that's how it uses CNN at the back end. So it all the data sets that we have was also having a label called age, and that's how it detects when it sees a new image. It tries to figure out what kind of range of age this person might be. So that's why it gives you a range, not a static age. Okay. One more thing is, can I write a ML model and use it in a skill? Absolutely, yes. That is the whole idea of SageMaker. All right, so I have few more, but I guess I can collate them, and maybe I will ping it to you. If you reach out to me over LinkedIn or Twitter, I'll try to answer all of that. Thank you so much for joining in. I would like to thank you for your patience, because it's I know that everybody are in mute. It's quite difficult to stay mute for almost 1 hour. So thank you so much for your time. I'm looking forward to your queries, and I would love to respond to you. Thank you. Back to you, Roy. Roy, Sakshi, are you there?
Yeah, hi.
Thank you, Suman.
Uh,
Thank you for the time. And thank you everybody for joining in our webinar. We hope you learned something today. We look forward to having you in our future webinars. Thank you so much.